All right, so you want to learn a little bit about the graphing calculator here. I am going to spend a couple minutes just graphing lines and maybe find the intersection of the lines, just some basic stuff on that. But I'm going to spend most of the time on the statistics stuff because that's what we're doing in class. So, all right, so when you start, you want to check out your y equals. Your plots on top need to be off. So if one of them looks like this, that's not a good thing if you're just graphing lines. Plots are for graphing points, ordered pairs. We're just going to graph an equation. So we'll go up there, hit enter, and come back down. Now everything's good. Your x key is right here, your xt theta n key. So if I want to graph something like x plus 6, I'll just go x plus 6, like that. And when I hit graph, it should graph nicely for us. Okay, now this um, is set up from a previous problem I had on there. So I want to go back to my regular window, which is like -10 to 10. So I'm going to hit zoom 6. So zoom 6, which will make then you can see the graph better. Now there's a chance you still might not see the graph. Like if I had y equals x plus 60, oops, not 0, 60. Well, if I had graph on that one, you're not going to see it on here. You can see it working right here, like it's there, but it's not. You don't see it because the line is way above the graph. It's way above your window. So you'd have to zoom out, or you could just change your. If you went to window, you could change your y maximum, so you could see it up above 60. So maybe I'll just go down there just to get that quick. So if I change that to like 80 or something, and I hit graph, at least you'll see it. Okay, so there's a line. Now this double line right here is the scale. So like right here, on the y scale it says it goes by ones. You want to probably change that to go by tens or fives or something. If I change it to fives, then I hit graph, you'll probably see the tick marks. See those tick marks now? So those will go by fives. A second ago, they went by one, so it looks like it's all filled in, so a double line. Not a big deal. I'm going to go to Z6 again, uh, just to get my regular window back. I'm going to go to y equals, I'll go back to that x plus 6. So I'll go there and I'll just hit delete that one, hit delete the 0. Now let's say I'm going to also graph another line with it, like 1/2 x minus 4, let's say. Okay. Now I have this set up nicely so they're both graphing at the same time. I want to change this so they cross on our screen here. So let's go to y equals. I'm going to insert. It's good practice for you too. I want to insert a negative sign here. So I'm going to go second delete, which is right here. That's insert a negative sign. So there it is. Now when I graph, you can see them cross right here. I was about to say, if you go to your mode, I have these graphing at the same time. If you go to mode, I have mine on simultaneously graphing. Most of yours default to sequential, which means it'll graph one line and then the other. So you might want to go down to this if you're doing this a lot and go make it simultaneous. It just makes it go faster. But this is good. Now let's say you want to find the intersection of these 2 points, of these 2 lines. One rough way is to hit trace, and then you can see the order pairs pop up on the bottom where your cursor is. So right now I'm at 0, 6. I'm going to hit my arrow and I can just follow this line down to about the intersection. Notice the points on the bottom that are changing where the cursor is. This is really slow. How about right there? So that's roughly estimating -6.6 and -0.6. So that's a rough estimate of the intersection, and there's the equation of the line that I'm on. If you want to switch to the other line, by the way, you could just hit the up or down key, and that jumps into the other line. So you can see what my cursor is now. It's over there. But if I want to actually find the intersection, there's a better ways to actually calculate the intersection. Now, there's 2 different calculates that we use a lot. One is in statistics. It's this calculate here, up on top there. And we'll do that in a minute. But right now, the other calculate we're going to do for this particular graph is this calculate right here. I'm going to hit trace again just so you can see it. So there's my point, my cursor. I'm going to use that calculate. So second trace. And now we can calculate the intersection. So just hit 5 or scroll down and hit enter, but it's just quicker to hit the 5. Now when you do this, it's going to ask you which curve, because you could have like 10 different lines on here at one time. But if you only have 2 lines on here, which you probably would only have on there, just hit enter 3 times. First curve, yes. Second curve, yes. And then it's going to guess. So hit enter again. And there's your actual enter. It brings you right to the intersection. And you can assume this decimal here, it really goes on forever. So it's probably -6 2/3, comma, negative 2/3. Just think of that as a fraction. And that's your intersection. That's all I really want to do now for the line stuff. I want to jump into the stats. So let's clear this out. Clear that out. And I'm going to use these problems from our CPM book right here. This is number 91 in our text. I'm going to have you input this data. And then when I get to 105, and I'm going to do 107. Different types of curves that we're going to do residuals for. And so if you want to pause this right now, if you happen to have a calculator, I would say pause the video and input all these in there if you know how. If you don't know how, then just wait 2 seconds and I'll show you how to do it. I already have these input for us. I'm going to clear that out. In my list, it's under stat and then under edit. So that's where you get to those lists. I have all those problems already in here. So I have all the way through list 6 here. So well, you'll just, these should be empty for you. If for some reason they're not empty, go up to L1, hit clear. I'm not going to do it now because I don't want to clear it. Hit clear and then enter, or clear and then arrow down. And that clears the whole list right away. And go over to L2 and hit clear that out if you have some old numbers in there, just so you don't have extras at the bottom. Okay. And then you simply start inputting the numbers. Just like put the number, hit enter till you're done, arrow over, and then hit all the numbers, enter till you're done. Now there's a checksum thing, because these first two lists are really long. Like this is X and this is Y. And this is all like all these X's is one big long sum. We're going to put this into list 1, and we're going to put the Y's into list 2. They have this checksum thing here, which is just in case you input like a decimal in the wrong spot or something. So I'll show you how to do that quick. Let's quit. If I go second mode, I'll just get out of here. And I'm going to calculate, let's go over to here. Go to calculate 2 var stats. 1 var stats will give you the first column. 2 var stats gives you both the first 2 columns just by default. So I'm going to hit 2 from 2 var stats, and then I'm going to hit enter. And it gives us all the stuff that we're not going to talk about till we get to chapter 10. But this is the one that I care about. This still summation key here. The summation of X is 198.9. Well, if I look at that over here, there's my 198.9. So I put the numbers in correctly. Most likely. I could have screwed up on 2 of them, I guess. And then if I scroll down a little further, because I did 2 var stats, I have the summation for the Y column also, 4070. And if I go back to the page right there, 4070. So then I know my numbers are input correctly. Now they'll do this in the text if you have really long lists. If you have shorter lists like this one right here, they're not going to give you the checksum just because you can visually see if you screwed up. All right, so this particular problem is talking about shoe size and height. So they're going to see, well, if you know someone's shoe size, can you predict their height? How accurate could that be? Or are they not necessarily could you predict it, but could you say that they're somehow associated with each other? Because we're not going to say this predicts this or this causes this. We're just going to see if they're related to each other somehow. So let's find out. When we have all that information in there. Oops, that's not what I want. I just want to quit. We have all the information in there. Let's calculate our regression line. Okay, now I did something on purpose here that we'll get to in a second. Now, we typically will do either 4 or 8. 8 is a plus bx, and 4 is ax plus b. In algebra, we're used to using like y equals mx plus b form, which is number 4. They use in the textbook number 8 often because this is going to lead us to like future statistics courses and stuff. We'll use this format a lot, where it starts with the y-intercept, and then you're adding the slope. Okay, so we'll just keep doing 8 just because to be consistent with the book. So I do that, I hit enter, and then it gives us all this information. Now this has, like yours might not have this, but I have my correlation coefficient right here, my R and my R squared. You might not. If you don't, and you won't like when you start a test because we're going to clear out all the memory, you need to go to turn your diagnostics on, which is right here. So second 0, which is catalog. And then jump down to D. Now your A right here, your alpha key is already on. So you can just simply hit the X inverse, which is D, that little green D right there. Jumps you down to D. And then I think I hit this like 10 times. And that will bring me down to diagnostics on. Okay, so you go down to diagnostics on, hit enter twice until it says done. The diagnostics are on, so when you do this stat calculate 8 to get your line of regression, that's your line best fit, you have the R's there then. So that should be there for the rest of the day. They're usually there forever until you clear out the memory, which we kind of do it every day in class. So our equation then is y equals a plus bx, which is like 131.2 is like our y-intercept right here, and b, our slope, is 3.9ish. So I'd say 3.97. I would do that if you're writing this down on the test or something. Give me some decimals. And let's graph it. So if I hit graph right now, nothing's going to happen. Okay. If I go, I need to turn my plot on. First of all, if I want to, let's say I want to plot those points. Now this is the quick way to move around the plots, like this. You also need to get used to second y equals, which is stat plot, because you can manipulate what parts you're actually going to be plotting. Like it always defaults to 1 and 2. And if you, like I'm going to use plot 1 as 1, 2, like our x and our y always. I'm going to go to do our residuals in a minute, and I'm going to change this plot 2 to something else. Okay. But right now we'll turn that plot on. So I can just hit enter right here. And then right there it's already on. So I'm going to hit enter. And then if you can see, if I get off of that, it's on. I could change you can see the X list and the Y list are defaulting to 1 and 2. The mark, if you want to change it to plus signs or dots, you could do that too. But that's on, so if I hit graph, they should show up unless they're not there. That's like they're outside of that range. So what's happening here is there's a shortcut that we can see all the points. If you hit zoom 9, that's going to get us our, there it is. There's all the points right there. That gives us the best screen, the best window to view our points. So anytime you do a graph and you don't see it, just hit zoom 9. It'll always give you the best look. And if I want to put the line of regression through the middle of that, that's because we already figured out what that is. I'm gonna put it in right there. So I'm gonna hit vars 5, I believe. Yep, vars 5 equation right there, and regression equation. So you'll do this a lot. And there it is. I'll plug it in there for you. And I'm gonna hit graph. And you can always see it's right there. So it graphs that line right through the middle for you. Now I'm also gonna ask you to do residual plots, which is taking the x and comparing it to the distances, these residuals right here, like this little, it might be a decimal, like negative 0.4 right here, or maybe a positive 0.2 right here. These little distances to the line. Well, if I want to do that, there's lots of different ways to do this, but one way that I think is the most, I don't know, convenient, I guess. Go back up to the stat plot, and I'm going to turn that first one off. So I'm going to go into this. I'll do that later. Let's go to stat plot 2. Instead of L1 and L2, let's make it, let's put our residuals in there. So I'm going to enter into this, sorry, go down to L2, right there. And instead of L2, I'm going to put in my residual, which is what we practiced in class, and I have in that packet for where we put it in list 3. We put all the residuals there. This, I think, is more convenient. So here, just go to list, which is second stat, and then number 7. And then that right there will give us our residuals. It will graph our x's versus our residuals. And just for fun, I'll make these plus signs. Just hit enter. Now right now, all our plots are off. If I go to y equals, oh, I can do the first one on. I'm going to go up and turn that off. I'm going to go over to plot 2, turn that on. I don't need this line right here because it's a different line, so I'm going to clear that out. Now if I hit graph, we'll get the residuals. Now we're not going to see it in the screen that we had, so if I again do zoom 9, there's our residuals. These are all the x's, and these are the distances up and down of those same points that we just saw before. Now we don't see too much of a pattern here, which is a good thing for residuals. You want scatter. You want randomness. The more random it is, the better your residuals, and the better your line best fit. Okay. I think let's talk about the correlation. Let's go back and calculate. Even though I already have it on there, hit 8 again. So I have this correlation. I just want to talk about this in the context of the problem that it is. The R is the correlation coefficient, and if it's up around 0.8, 0.9, that's pretty good relationship. If you look at the line that goes through the best fit, and if I go back to stats, turn this one off. Oops, I gotta go up where it was. Turn that on, turn that off. If I hit graph and hit zoom 9 again, okay, then this, oh, I don't have the equation in there, so I got to put it in there. Where was I again? Virus 5 equation. It's good practice for you to go through this again. And then graph. Okay. Now these dots are kind of lined up. You can see a pretty good relationship with a line versus them being curved or totally random. That's why when we have our, if I quit out of here, if I show your calculate 8 again, just so it's up there, that's why our R is pretty high. It's a pretty good relationship. If you look down here, this relationship, this line is a good indicator of where the dots are. R squared then in context, because I'll ask you about that too, applies to the real world. This is a percentage basically. You can say 74% of something is related to something else. Okay, now the something depends on the problem. So this was what the shoes and the shoe size and the height. So you could actually say the statement 74% of the variability in the y value, which in this case is the height, because we happen to do this first and then the height versus the other way around. So 74% of the variability in the height can be explained by a linear relationship with the shoe size. Okay, that's how you can interpret that. Oops, where was I? I want to go back to the calculator. That's what that 74% is, just rounded to the percentage. Okay, let's move on to this problem here. So if you're using your calculator, go ahead and pause this and input all of these. You can just put them into list 1 and list 2 again. Clear out your lists first. Again, if you're going to do this, go up to, that's not what I wanted. I wanted to go to stat, edit. Go up to the list 1 and list 2 and hit clear, and then enter down and then clear that. Or just go to list 3 and list 4. If you want to be consistent with what I'm going to do right now, you might as well just put them in list 3 and list 4, because that's where I have my points put in for you. Okay, so go ahead and do that. And let's do the same thing again. Okay, now we have those points put in. This is, I'll just glance at this quickly. It's talking about, I'll just read it. Top it all off, makes numerous lids for a variety of containers. Some of the most popular lids they produce are circular lids for oil drums and cylindrical containers. Although the lids are ordered by the diameter of a circle, the price is set by amount of metal used. So I'm going to refer back to that in a minute. That's why I wanted to point that out, because the context of the problem kind of means a lot. Let's go to stats, calculate. Now if I do 8 again, it's right now it's going to default to list 1 and list 2. So if I do list 3, which is second 3, and then comma list 4, okay, that should give me the regression for those. Now I can automatically put this into the y equals. If I put comma y1 right now, I could do that right now, but I'm just going to keep consistent here, even though it's a little bit longer. If I hit enter here, it gives us this information. Okay. Now this is all fine and dandy. We have a line. Okay, let's go ahead and graph this. If I go to plots, so let's go plots here. Now, right now it's plot 1 is on with 1 and 2. I want to change it to 3 and 4, so I'll just go into this first one. When I hit enter, change 1 and 2 to 3 and 4. So again, second 3, second 4. You might not have to do this if you're just using list 1 and list 2, but it's handy for you to know this. This is on. If I hit graph, let's see what happens. Well, I see a line, because I don't want that line in there. Let's clear that out from the previous problem. Now when I hit graph, don't see it because my window's way off. So I'm going to hit zoom 9. There it is. Okay. Looks, now if I go y equals, we already have that regression line in there. And if I copy and paste it basically in there, I'm going to go virus 5 equation. Do this enough, it gets second nature kind of. And graph. Makes a nice line right through there. Okay. Now, if you glance at those points, you can see there's kind of a curve there to them, and it's kind of subtle. If we look at the residuals, we'll see it a little more obvious. But it looks like the line makes sense. If I do, if I go back to where that was, calculate the stuff, I probably could have just said quit. 8. It's got a decent, strength to the correlation, and you can do 74% here, so it all looks like it's all right. But sometimes there's a better line, in this case a curve, that could go through there. Let's do a residual again, which is, I believe, plot 2, if I have that still up there. So I'm going to go second. I want to double check here. Yeah, I have residual here. That's my default now for, not default, but I put that in there. So if I turn plot 1 off, it's quicker for me to just do this. I'm going to clear that out of there. Turn plot 1 off and turn plot 2 on. Now when I graph, I get the residual graph. Well, all those points are jammed in right here. Okay, so zoom 9, and then we'll have a better idea of what's going on here. All right, I did a little tweaking and I had to pause the video. I moved my columns over here when I wanted to edit here, just because it's going to be quicker for me to work with what I'm about to try. Instead of 3 and 4, I might try it with the 5 and the 6 later. We'll see. Back to where I was. So I calculated 8. Oops, that's not where I want to be. I want to be, let's quit here on this screen here. So if I go stat, calc, and I hit, why am I doing this? Quit, stat, edit. Huh. I'll pause it. All right, I'm definitely overtired here. Stat, calculate, 8. There's a line regression. Okay, now when I graph this, it may or may not show up on my screen. I hit zoom 9. There it is. Now, oh, this is my regression line. What do I have on there? Oh, I got my plot 2 on. Let's go back up to this. All right, now when I graph, zoom 9, you can see parts of it. Zoom 9. There, that's what I was looking for from before. So it looks like I can draw a line through here. Okay, so if I go y equals, and I do my regression line, so I plug in vars 5, equation, graph, a line goes through there. Looks like a decent line, but I want to see if there's a curve that fits better. Okay, so in the way I can check to see if this is really a good line or not, I go to that stat thing I was just on, or residual plot I was just on a second ago. So if I go to my residual plot, which is, I go back up to here, or just go to y equals. So click on that. I'm going to clear this out. I'm going to turn my plot 1 off. Turn my plot 2 on. Now when I hit graph, I'll get that picture I had a second ago. Like I have this, okay, which is my residuals just above and below the x. If I hit the zoom to get a better picture of it, zoom 9, you can see there's obviously, it's not a random thing here. There's definitely a pattern. It looks like a parabola. So if you don't get randomness here, there's probably a better way to graph this, which is with a curve through here. So let's try that. So let's go to calculate. So stat calc. Right here, number 5 is quadratic regression, which is power of 2, like parabolas. There's other ones too, cubic, and you can go down to number 10, which is exponential. So if I just do that, go to number 5, calculate that one instead of the line, and then this is ax squared plus bx plus c. So there's my a, there's my b in front of the x, there's my c. Now here they just give us r squared, and I want to warn you, this r squared was figured out differently than the linear regression r squared, so don't try to compare those two. But that's there. And now if let's go back to y equals, let's plot, or let's put in that equation there. So vars 5 equation, that regression line, okay. If my calculator does something goofy here, I don't know if it'll work or not, but I'm going to go up to plot, turn that plot back on, and that plot back off, and graph that. I do get an error. I want to go to Let's do that again. Y equals, I need to go over, for whatever reason on this calculator, yours shouldn't do this, but mine doesn't put the x at the end there. I thought it was there. Oh, I gotta put the x squared there, I think. Let's try that. Yeah, there it is. Okay, now if I do zoom 9, there it is. So there's my dots, and there's a better curve. Instead of the straight line that went through it before, we have a curve. And then if you check out the regression, so if I go to y equals and turn the plot 2 back on, maybe I'll clear this out. Go up to plot 2, plot 1 off, plot 2 on. Now this is, again, if you remember, if I go to this is residuals. Okay, so my plot 2, I just made it so every time I go to plot 2, it's my residuals. When I graph that, all my residuals you can't see, but they're really close to this line right here. Okay, so if I hit zoom 9, get a much better view of that. There it is. So what does this mean? Well, it's random. That's a good thing. So this is a much better fit to the curve than the straight line that we had before. Before we had that parabola looking thing, that was a pattern. We don't want a pattern. So this is much more random. If I look at, if you want to say, well, what are these values? Again, hit trace. And then here, this ordered pair right here is 10 over, and then -4/100ths. So that's why we're zoomed way close here. So this distance is 4/100ths only. This point here is 12 over, and then 3/100ths high. So that's why is a much better fit for this particular problem. And if you look at the context of the problem, you could probably, oops. All right, so we had a little interruption for an announcement. We'll pick her back up here. If you look at the context of the problem, and this is why I pointed this out, the diameter, circular lids, well, area of a circle is pi r squared. So it has something to do like this radius squared. So the diameter has some influence or is affected somehow by a square of something. Okay, so there's a square involved, probably going to be using quadratic or possibly exponential, but quadratic in this case. And let's go to this last one. If you want to try this one quick, just buzz this one in or put this in your calculator. This talks about dry ice and it evaporates. And you'll learn through experience when you do problems about evaporating and stuff, this is an exponential type of thing where you have like a bunch of ice here and then maybe like half of it's gone. And then after another hour, half of that's gone. After another hour, half of that's gone. Another hour, half of that's gone. So this is called exponential decay. This is actually going to be talked about more in our next chapter. But that's what's going on here. I'm not saying this is the actual problem, but that's a similar situation. So when I do this, I'm not going to try to put a line through it necessarily. I might just go right to the exponential. And then just to save some time right now, that's what I'll do. So I believe I have these in. I wonder if I don't think I need to recopy. I'll try to see if I can figure this out with what do I have, 5 and 6 here, I think. I have them in my 5th and my 6th column, so I might have to just change a few things here. Let's go ahead and do residual line for these. I'm trying to think if I need to delete anything. Let's go second plot. I'm going to plot, instead of L1 and L2, I'll do L5 and 6. You know what, I'm going to pause this for a second. I think I'll just kind of cut this shorter and I will just do the actual regression line. So I'm going to go to stats, calculate, and 0, which is down, it's way down there. I'm just going to hit 0. So it's exponential regression, just because I know the situation is more an exponential. If you try the other ones and you try the residuals, you'll see that they're off. This is going to be the best one here. So I do exponential regression. Now this is going to default to list 1 and list 2. I want 5 and 6 just because of mine. You're not going to have to do this probably. But if I do list 5, comma, list 6, I could put this line right in. If I put comma y1, I could do y1 right here. I'm not going to do that. We'll save that for another lesson. And I just hit enter. And it gives me this a times b to the power of x. So that's exponential growth or decay. Now because this r is negative, it's going to be decay. Let's go smaller. My starting point is 15.3, 15.4, and then you're going to multiply it by 0.96-ish each time. So it gets smaller and smaller and smaller. Okay. If I can graph these. Let's go plot. Let's change this one to on. Oops, that's not what I meant to do. Enter. Change that to L5 and 6. And then that's on, that's on. If I want my line to go through it, let's go y equals. Oops, let's quit out of here. What did I just do? Clear. 5, 6, on. If I hit y equals, I should be able to put it in right there. I want my plot 2 to be off, by the way. That's my residual plot. I want to put in my regression line, so it's vars 5. My regression curve in this case. And now I think this is the same situation where I have to put an X here. Otherwise I'll get the error. I think this is okay now. And then it's obviously my window's off. I'm just gonna talk right through this bell here. All right, so I can finish this video quick. This is really dragging on. Bell rang. Okay, zoom 9. There's our line. There's our dots, and then there's my curve that goes through that exponential decay. That's what we wanted. Hopefully that's enough information. I think 31 minutes is enough time to babble at you guys.